Welcome to Relational Database Design. My name is Ken Walsh. Functional dependency. It's a big word, but a fairly simple concept, and it just means what information determines other information in the relation. So, for example, if I know your employee ID, then I can definitely determine from the system your first name. However, if I know your first name, I cannot determine your employee ID because there could possibly be multiple employees with the same first name. So functional dependency, what attribute is dependent on or can we figure out from another attribute? So generally, from what we've said so far, most of the attributes we can figure out if somebody tells us a primary key. The concept is pretty straightforward, but we're going to look at some places where it may not be true, and that'll indicate a problem with our database design. So normalization now is the process to check our relations to see if we have a consistent design that minimizes redundancy, minimizes the number of changes that need to be made when a piece of the data changes. These are called normal forms. We're going to look at three levels. We're going to look at first normal form, second normal form, and third normal form. These all build on each other. So first you say, hey, is my set of relations in first normal form? If it is, move on. If not, fix that type of error. And then move on and check, well, is it now in second normal form? Again, a lot of terminology here, but the concept is probably less confusing than the words. Let's take a look at the forms. First normal form. First normal form means no repeating groups. That's the rule. So if we look at this incorrect example of a student relation, we have the name of the relation is student. Primary key, student ID. Another attribute is first name. That's all well and good, but when we get to the next attribute, course section, well, a student might be taking more than one course. So course section then becomes a repeating group. So first name was not a repeating group. They just have one first name. Course section, however, could repeat any number of times. Since that's a violation of first normal form, we rewrite the single relation into two relations, correcting the problem. In the corrected version, we have student, primary key, student ID, attribute, first name, remains in the student relation. Course section was pulled out of that, and we made up a new relation called courses taken. And the primary key is a compound primary key combining the course section number and the student ID. Now, we won't, if a student were to take two courses, instead of having a repeating group as we did in the first example, we would have two complete rows of data in the courses taken relation. All right, and note that compound primary key, course section, and student ID. So if a student takes two courses, that student ID will show up more than once, but it'll show up only once in combination with a course section number. You can see also the attribute grade will not be a repeating group because it'll just show up once for that primary key combination of a course section and student ID. So once it is in first normal form, or we found no first normal form problems, then we move to second normal form and say non-key attributes functionally dependent on the whole of the primary key. Well, you can only have the whole of the primary key if a primary key has parts. Remember that last example? We had a compound primary key, course section combined with student ID. Okay, if you have a combined primary key, but only one part of that primary key is determining some of the other attributes, that means they need to be broken out into a different relation. So let's take a look at the incorrect example, courses taken. Course section, student ID, compound primary key. The grade the student got in the class. It's functionally dependent on that whole key, both course sections, student ID. If you tell me the student ID, I can't tell you the grade because they might have taken more than one course and they might have gotten different grades. But if I tell you the course section and the student ID, well, there's only one grade for that full primary key. Here comes the problem, is the building ID. The building ID can be determined by the course section only, right? Because every student in a particular course section is going to meet in the same building. So it won't be different for Bob and Jane, won't have a different building. They're taking the same section of the course in. So building ID is functionally determined by course section and course section alone. You tell me the course section, I'll tell you what building it's in. Therefore, that's functionally dependent on part of the primary key, violation of our second normal form rule, and we have to pull that out into that building ID attribute must be in the section relation rather than the courses taken relation, and see the corrected version. So section ID and student ID functionally determine grade, not a problem. Section ID by itself functionally determines building ID, so building ID must be an attribute of the section relation. Moving on to third normal form. Third normal form means we're already in second normal form, but we have no functional dependencies between non-key attributes. Okay, so for example, if we take that section relation again from our last slide, the section ID is the primary key. The building ID is functionally dependent on the section because we say that section is going to meet in a building, so the building ID is determined by the section ID. However, the building manager, well, in a sense, the building manager can be determined by the section ID, but the building manager also can be determined by the building ID. So now we have an attribute being dependent on another non-key attribute. So building ID, which is not the key attribute, determines building manager. Therefore, building manager is in the wrong relation. The corrected form, section ID, section ID, primary key, building ID, not a problem. Building manager is moved to the building relation. The building relation has building ID as a primary key, and now building manager ID is functionally dependent on building ID. Those three rules you need to look at for every single relation that you ever develop, and look for those types of corrections. A lot of times an early design will violate one of those rules, and those rules will point to the fact that another relation needs to be added to the design. Another way of doing relational design is sometimes you begin with an entity relationship model. The entity relationship model may have been, already developed, had a lot of input from business people, but now needs to be converted to a relational model so that it's much closer to what can be implemented in a computer. So here's an example. A customer places an order, okay? The cardinality is a customer places from 0 to many orders, while an order is placed by one and only one customer. And when you have two entities in your ER diagram, one relationship, and you have a many on one side of that relationship, it results typically in two relations that correspond to those entities. So you have the customer relation, customer ID is the primary key, first name, other attributes, order ID is the primary key. So that's when there's a one's on one side and a many on the other side. The cardinality shows us that we only need two relations. Let's look at another example though. In the student section relationship, or the student in the places relationship with the student and section entities, we allowed for many on both sides. So a student places from 0 to many sections, and a section is placed by 0 to many students. Okay, many on both sides. We end up with 3 relations after we normalize. So student follows from the student entity. We have student ID as the primary key. Its section follows from the section entity. But because there are many on both sides, we cannot put a foreign key of section ID in the student relation, and we cannot put a foreign key of student ID in the section relation. In either case, that would result in a repeating group. Repeating groups are not allowed, so we make the student section relation, where student ID combined with section ID is a primary key and grade is an additional attribute. Second example with the many on both sides of the relationship in the entity relationship model. An order contains many products. A product is contained by many orders. The order and product relations follow from the order and product entities. But a new relation, order line, with primary key, order line ID, and line number has been added. And this line has the foreign key, product ID. So, and the order ID, which is part of the primary key, is also a foreign key to the order table. Just a slightly different example. With order line, we used order ID and line number as a compound primary key. Kind of fits a little bit more with the business model. We could have gone straight to order ID, product ID, like we did in the last example, and combine the primary keys of the other two relations if we wanted to. So in summary, don't confuse a relational model in the ER diagram, right? The words are very similar in the two models, but they mean different things, so you got to be clear on which one you're talking about. The relational model is the heart of relational database design. Once we have a normalized set of relations, now we're pretty close to being that combined with the data dictionary allows us to go to the computer now and implement the database on a computer. In practice, first draft may need to be modified. Design problems are not always noticed until the attributes are defined. Right? Is that the correct relation to use? Is it normalized? Well, we have to check all of the attributes. If new attributes are introduced, a change may be needed. Thank you, and good luck designing relational models.